A median. A segment. Shh. That joins a vertex. And the middle of an opposite side. Joins a vertex in the middle of an opposite side. Medians are concurrent. At the centroid. Okay.
Staying out of this conversation.
What is a centroid?
Centroid is a point where the medians all intersect. Center of a triangle. Alright, so if you take a segment, again, it goes from a vertex to the middle of a side.
Oh, I see.
Okay? Vertex to the middle of a side. And vertex to the middle of a side.
So it's not a bisect.
It doesn't bisect the angle, it does bisect the side. Okay? So this piece is congruent to this piece. And these two are congruent. And these two are congruent. That is called the centroid. It's not. In-center is equal distance from all the sides. That's not going to be equal distance from the sides. Alright, the other thing that's real important when you're talking about medians and the centroid. Excuse me?
Is there a median to a median?
No. This piece, you see this piece of the median, the longer piece? And then you got a shorter piece, right? B to G is a longer piece than G to F. Agreed?
Yeah.
And C to G is longer than G to D. Okay, look. A to G is 2/3 of the distance of A to E. This piece of the median is 2/3 of the way
Will always be 2/3.
from A to E, and G to E is 1/3 of that, the length of that whole distance.
Is it like that with CG?
It's like that with all of them, yeah. Okay, so if DG equals 4, if that piece equals 4, all right. Look, the shorter portion of the median is half of the bigger portion, isn't it?
Yeah.
1/3 is half of 2/3. So if D to G is 4, what is G to C?
8.
Good. And what is D to C?
Oh, that's 12.
Good, that's 12. You see that? This is a third of the whole distance. This is 2/3 of the entire distance of the median. The whole length of the median.
So DG would be 2/3 of
No, DG is 1/3 of DC. If B to G equals 9, that piece right there is 9. Then G to F would be good, 4.5. And B to F would equal 13.5. Because if that's 9, then this has to be 4.5. The smaller piece is half of the bigger piece. See, the 1/3 is half of 2/3.
You just made it a mess up number.
Yes. Sound good? All right, and altitude. That's a segment from a vertex to an opposite side that intersects at 90. Altitudes are concurrent at the orthocenter. Got it? So a diagram. You can catch it on headline. All of this can be viewed at edline.net. All right. From a vertex. Now, if I go to this side, am I going to intersect at 90? What about now? Look, it's got to happen out here. An altitude goes from a vertex to the opposite side and intersects at 90. The other side can be extended. Okay? So it's right. There's your altitude. There's one of your altitudes. Look. There's only 3 because it's got to start from a vertex. Vertex to the opposite side. Is this going to be 90? Is that? So it's got to be out down here, doesn't it? Probably about there. This side extended at 90 degrees. Okay? And now vertex to an opposite side intersects at 90. Right about there.
So should it intersect the vertex?
An altitude starts from a vertex and it intersects the opposite side at 90 degrees. But some of the times the opposite side has to be extended outside the triangle so you can find that point where they intersect at 90 degrees. No. Alright, now these three red segments here, where are they going to intersect? At the ortho center. Where's that ortho center going to be? It's going to be down here somewhere, isn't it?
Oh yeah.
Yeah, look, extend this. Extend this. And extend. Oops. Yeah, that would have been better. Oh,
How did that happen?
that was bad. I was trying to erase this red line and it just didn't. It did that when I did it, so that red line should have been a little bit lower. But that's where the ortho center would be if you can picture all that. You probably got an eraser that works.
Is the ortho center always outside the triangle?
No. No, in a right triangle, it's actually, if you had a right triangle,
Yeah.
it's right on that right angle, isn't it? Yeah. You mean an acute?
Yeah.
Because vertex to the opposite side at 90 is going to go there. Vertex opposite side at 90. Vertex opposite side at 90. They all intersect right here. That makes it a right triangle. So an acute triangle, because this is an obtuse triangle. That's obtuse, and they meet outside. And then if you did an acute triangle,
They'll meet like in the center.
vertex opposite side at 90. Vertex opposite side at 90. And about there. So it's going to be inside. But when these get real obtuse, this point gets really far away. It's probably some kind of a relationship between this angle measure and how far that point is outside the triangle. You know, like every degree over 90, it's another so many units outside the triangle. And this is probably right in the dead center of that triangle when it's all equilateral. Got it? Any questions? Page 327, 1 through 17.
Is there any formulas you need to know for
The only measurement stuff you need to know is for the centroid.